Hello, welcome to Hydra Book Reading Club. I think it's number 4. And in this series, I'm going to be reviewing Hydra book, which is not a physical book, but it's an online book that I wrote some time ago. And going through like topic by topic, I will demonstrate and talk through the rationale. But also, it's been some time since I wrote it, so it's actually quite surprise to me, and especially this topic today. I'm quite excited because you can see something in the background, which I was like trying out things before. Well, this is kind of ad hoc, the video itself, but also I do prepare a little bit before filming, and some spontaneous things happen. But this is something I made before. Well, now I'm talking, so I did it before. Although you can do some post editing. No. Anyways, so there are surprises, and I hope that this is inspiring to you. At least it's inspiring for me. I might use this new technique or old new technique that I made some time ago that I am adapting now. And it's very exciting to see different ways of crafting images in Hydra, because I don't think there's like a lot of people like there are like tutorials on Hydra. Well, not many, but there are tutorials, but also like kind of more like methodology or like method how to craft images. It's not really common. I think everyone build up their own way of building things, but also I think there are like something that can be like having in common with other people, and that's something I'm explaining. Like, so this is not about this function, how to use that function, but it's about like how to combine it, or like as technique, like a combination of functions or just more like ideas, concepts that you can use in your live coding. So yeah, and disclaimer, I'm just back from Japan, and now I'm in the studio at Tallinn University where I study and teach. So yeah, I'm a little bit all over the place. This video may be a little bit short because this is like one specific topic I want to talk about, but it's very exciting, and I hope that is useful for you too. All right, so let's get into the topic. So I will make myself small like this. And I already deleted the code because, this is my philosophy about live coding. I always start from scratch. But good thing is that we have this Hydra book as a reference. And what I'm gonna do today is, so last time we did this, and sorry, like there was like some mix up with like publishing videos and so on. So there are some things that were published before was not supposed to be published before. I'm a little bit all over the place, but that's kind of live coding as well. So you cannot control everything. All right, so let's look at this one, and I'll just like, I think I memorized this. I mean, not memorized like exactly, but like I'm gonna use this as a kind of starting point. So the idea is that I have a like square. I mean, it doesn't have to be square actually, which is maybe also interesting to explore later. But let's start with this. And what I'm going to do is, I don't know what's the title, scaling and feedback. I mean, I also use like scroll and things afterwards in Hydrobook in this section, but it's about scaling and feedback. I mean, to make geometry, because this is a geometry chapter, and I'm using like feedback to create some kind of geometry, and that's actually quite similar to the fractal that is in the intermediate tutorial, I think, that I recently made. So the idea is that we use this feedback from the previous buffer, maybe scale it down or shift it, and use that in a new texture so that we can make like intricate pattern, like, or recursive pattern, repeating patterns, and so on. So that's kind of the idea, to make the geometry. And the way I did in that example is I use diff. And so basically it's very simple. Just we make this shape and take a difference from the previous frame, but the previous frame will be slightly like shrunk. Oops, I forgot dot. Okay, let's see what's gonna happen. So this is what it is. Because of diff, the nice thing about diff is that it will how to say, it's more like an invert, right? Because we're just using white color and black color right now. So if you take diff, the white part, difference with the white becomes black. I mean, very simple math. Like you can use 255 or 1 as a white color, but if you subtract 1 from 1 or 255 from 255, then it will end up 0, which is black. But also 0 part, if you take like 0 minus 1, you will end up with -1, which is not white, which is like some kind of negative weird color. But the nice thing about diff function here is that it will end up with an absolute value. So -1 will end up with 1, which is white. And that's really helpful in this very specific scenario, because if we have, like, for example, we cannot use sub. I mean, also sub function has another problem. Sub is for subtract, but also it will subtract alpha channel as well. So it will end up with, well, I can try, but basically, oh, it's flickering. That's not really good. And that's really different. Like diff and sub, they do very different things. And also, like, something I noticed in this specific video today, I'm going to use hush quite a lot, so that basically it will clear everything. And I think it was said, thank you for commenting. Hush function is like very useful, because if you just do this, it will just clear everything. Nothing will be rendered. It's just black. I mean, probably transparent, but browser cannot be transparent, so you see the backdrop black. But still, you can have these functions here. When I evaluate, I just use Control Enter, so it's just one line, just one line of hash will be executed, and these one will be untouched. So if I want to go back to this, I will just do, in this case, Alt, or on Mac it's Option, Alt Enter, Option Enter, and then you can do this again. And if you mess up something, because we're using feedback, you might want to clear everything before like changing something like I did this time. I might want to do hush first and evaluate this one. We'll see this. So this is a very simple way of like, now it's like a kind of geometry. It's not a grid, how to say, it's like square inside square inside square. Okay, it's a rectangle, but okay, whatever. So this is a very simple way to do it. And also in the examples, I think I did rotate. So what if I add a little bit of rotate? And this time I could also do this, but also I can just clear it just to be sure, and then evaluate it again. So it's the edges are a little bit funny, but you see the idea that this square or rectangle is like rotated and shrunk, rotated and shrunk, so you can see this kind of very interesting pattern happening. So also, I think you could move it. I don't use this arrow function so much, but we can start with this. And a simple way to oscillate arrow function is, if you're like using like P5.js or processing, you may have this pattern a lot, like sine function with time inside. Also you can multiply with 0.14 to make it more like periodic, like to close to seconds. But you can just do math.sine time, and because sine will output from -1 to 1, I'll just make it a little bit smaller, like 0.1. Then let's see what's going to happen. So what's something very specific about this is that it is rotating, but also it's making the feedback, so it's not moving all together. Like, maybe I can exaggerate this a bit, because this scale function here that it says 0.9, but if I make it closer to 1, what's going to happen is that, okay, maybe before everything, I will revert this. I'll just copy this part, I will cut this part, so I'll just make it static, and maybe like scale 0.95 or something. So, okay, it's kind of doing some funny overlapping part too. Maybe I want to make the rotation a little bit smaller, something like this. Okay, so it fits in the frame, and now I have more lines or squares in the frame, and then I do this math sign time thing again, then what's going to happen is that you start to see that this is like, it has some kind of delay, because feedback is not happening all at once, but taking one frame, shrunk, one frame, shrunk. So this rotation with math sign time will not apply all together on all the squares, but it will affect next square, next square, next square. So you see some kind of like a little bit like a springy movement here. So I think that's something interesting. And also, this time I use rotate, and I don't think in the example there's something similar, but you could also do not scale, scroll. Let's say scroll X, and maybe I do the same thing. That okay, let's just do something simple. Scroll X, maybe 0.01, and let's see what's going to happen. So it's almost like a perspective, like a corridor that, and spoiler alert, that's like something very similar to the example I showed at the beginning, and this is like where it's going, right? So you can make some kind of corridor, and then if you do this math sign time technique again, then what's going to happen is that you can see that almost like we're making like a 3D video game that, you know, you're kind of changing the direction or perspective inside the corridor. Or maybe you're like running through like this kind of snaky path of the corridor, or you can think about different ways, and you can actually like make it more like interactive as well if you want to like map mouse position to it, or if you want to make a website with this and add JavaScript to some kind of face tracking, you can actually make parallax, like, you know, you move the face and then it will track the face, and according to this face position, shifting this corridor, which can be like a super interesting project to do. And it's totally doable. So if you're interested, maybe you want to try that out. Maybe not on the Hydra editor, because Hydra editor with, for example, ML5.js, it's possible, but it's a little bit tricky. So maybe it's easier to set it up on your website. But okay, so that's maybe just like getting like more ambitious about this project. But so this is quite fun. And what's written in Hydra book is that I might skip this Voronoi thing, because I think it's a little bit too, it's kind of interesting pattern, but I don't know, I'm not so interested in this. But for example, like this one is very interesting, because what's happening here is that it ends up as a line. So basically, if we don't do scaling, and let's just do scroll X like this. So, and this is, I'm intentionally making it different from the example to see what's going to happen. So the idea is that I start with the same shape, like square shape as a starting point, and take a div, but this time no scaling, but scroll X 0.01. So it's shifting towards X direction like slightly and taking div. So I expect that it will end up something like this, right? And it's almost identical, the code. But what's going to happen is that it has this like, okay, I have to stop it because it's very flickering. The reason why this is happening, and it's not as like, this is tidy, it doesn't have this flickering effect, but what was happening here was like flickering. What's because I made a mistake, quote unquote, but it's not like mistake per se. It's about how to make this feedback like under control, and for this purpose, like you need to take some specific steps, and one of them is, for example, like doing div. But also in this case, because we're not using scale, it might like just go outside the frame, and that's what's happening with scroll X. And if you have followed all the videos I posted, well, you don't have to, but scroll X has this property that if you go outside the frame, it will kind of wrap back into where you are. So I can just demonstrate like something very simple. Like I can even do shape 3, and so this is this, right? And if I do like scroll x and 0.1, something small, then you see it's still in the frame. But if you say like 0.5, which is like half of the frame, and it's kind of already coming back into this into the frame. And if you do scroll x1, it actually comes back to where it was. It just like wrapped around and came to the same space, same position. So in this case of like making feedback, it's not so ideal. Well, actually not ideal at all in this specific case, because we make this like diff feedback, and if it wraps around, it just continues and continues and continues. If it goes outside frame, we want to like ignore it. And for that, in the Hydra book I showed here is using a mask function. So after taking diff, I have another like extra function here, which is mask, and it's kind of arbitrary. I mean, I can just like copy the same thing. For example, like this becomes, well, it's literally a mask, and scroll X can go outside the mask, but we're just saying that, okay, if we're like bleeding outside the space and kind of wrapping around, we don't want that. So just like trim that out. So what's gonna happen here is that, okay, it's still flickering at first, but it ends up something tidy. And whatever goes outside frame is like completely cut out thanks to this mask function. And I should have, in the Hydra book, I should have done one more thing, which I found super cool, is instead of like just scroll X, what if you do scroll X and Y? So for example, if you use scroll function, you can have X and Y as first and second parameter, and maybe I can shift it a little bit. So 0.01 is X, 0.02 as Y, and what's going to happen is something like this, for example. So you have something that is how do you say, like this perpendicular, orthogonal, whatever, like right angle going through the space, which is super interesting. Or what if I make it a bit bigger? Yeah, like you can kind of modulate the amount of, well, we can kind of control the angle or the thickness of like vertical and horizontal lines, for example. And I think I kind of forgot how I did something super interesting earlier. Maybe the mask, what if I change the mask size? So this and this, I have different ones. Okay, so probably this is what I did earlier, something similar to this. So in Hydra book, I kind of naively took this shape for 0.7, 0 as a kind of starter rectangle, and using the mask, like same shape or shape function as a mask. But what if I allow the mask to be a little bit, how to say, to go out a bit outside, and then it makes this kind of funny dotted pattern outside this. And I can exaggerate this if I say the shape is like 0.3, but the mask is 0.9. Oops. Yeah, I think this is what I was trying to do, which is like exaggerating this kind of repeating chessboard, let's say. And it's funny because chessboard, I had this, like affection to chessboard in some videos, some earlier video, and I was like trying to make the pattern in different ways, but also this is like another way of making chessboard. I mean, it's not covering the whole space with chessboard, but if you take this, like zoom into this part, it's chessboard. So you can also use feedback to make chessboard, which is really fun. And what if also I put some color to it, because we like colors, and I tried this one first, for example, to make it red color 100, like very simple way to make color, but it's just changing the whole like white part into red, which is okay. But another way to do it is, for example, not mask, multiply, my favorite pattern, which is like OSC with the third parameter 1.6 to shift the RGB channels. and that will make some kind of interesting pattern here. And basically, that's how I ended up in the first sketch that I was using as a backdrop, and I was just combining these things, but also like what I would, from naturally, like what I would do is to use scroll, like first parameter, like scroll x as the arrow function. How I did was math sine time, right? And probably this is too big, so I want to like multiply by, I don't know, 0.03, just arbitrary. And whoa, okay, this is quite wild, not what I expected, but you get the idea that it's doing this again like a parallax thingy. I don't know why it's like so big, the shift. Okay, something like this. Oh, maybe because of the mask parameter that is now 0.9 versus it was 0.3, so maybe I do it like 0.7, then okay, something like this that is similar to what I had in the first backdrop. I could even make like, oh, okay, I think, sorry, I think the reason why it's different is that I also had scaling in the first one. So what if I do this? So yeah, so basically it's almost like how I made the sketch in the first part, like the introduction. So you can like, combine these like scroll and scale, and if you need, maybe this mask will help you not to have this crazy like flickering pattern with a feedback to make interesting geometry. And one more thing I want to do is instead of the scroll, I might just keep a bit of like scroll Y. So with this, it will probably just go to like a corridor, yeah, from like looking from the center, but shifted slightly in Y direction. And instead of doing scroll X with arrow function, my favorite way to do something similar is modulate. And for example, OSC 1, 1, and I think this I explained in the modulate video in the, I don't know if it's a beginner or intermediate, but somewhere there I think there's a modulate topic that, sometimes you want to make this pattern a little bit, how to say, rough, or no, like not too detailed, like not like OSC like 60, but maybe like OSC 1, noise 1 instead of noise 10, to make it a bit more interesting, like pattern to emerge instead of like going just crazy noisy pattern. So something like this, and I think this itself is already super interesting. I just use the second parameter 0.01 because to match the kind of the scale we were working on, and maybe this is too much, too small. Oh no, I think it's okay. So now we can see that this corridor is again like moving, but slightly different way. I might also want to do like brightness here, minus minus 0.5, so that, because if we do modulate, this value goes from 0 to 1 instead of minus 1 to 1. If you want to make from 0 to 1 to minus 1 to 1, you might want to add brightness minus 0.5 to shift it, offset a bit, and maybe enhance this a little bit. So, and also modulate is modulating in the vertical, okay, maybe it was too much here. The vertical shift as well, so I do color 1, 0. Maybe this is not enough explanation here, but you see now it's like, it's basically, I'm kind of like emulating this arrow function by this very lengthy way. But the nice thing about this lengthy expression is that if I start to enhance this frequency, then you can see that maybe I want to make it like this, and you start to see that maybe this is not enough. Maybe I have to make it even bigger. Yeah, so I can also hide the code, and you can see that it's not just like doing this parallax, but it's kind of like starting to get wavy. maybe I should not do this color thing. Yeah, now you can see that it's distorted in a very OSC way. So it's not like the whole frame is like uniformly moving from one side to another, but you can see that it starts to like have this like waviness to it. You can just say this is trippy. Again, I tried not to say trippy because that's like, okay, that's the limitation of my vocabulary. But anyways, so yeah, I hope that this will be like interesting for some of you. Especially, I mean, the what I want to say is that you can use this feedback and also combine with like shape mask to make it not to go crazy, but you just keep it under control. So you have this feedback just precisely happening in this little frame, and you can have like, you can craft almost like, you know, these patterns. I can also get rid of this OSC, like the color. You can see that this is like a little bit more, how to say, crisp. And I can also like, I don't usually share the code, I mean, explicitly. It's not that I'm hiding. I thought that you can just like copy it, I mean, by typing from the video, but I can just copy this URL so in the description below, so you can just go there and use that as a template, and you can just, you know, start with like editing numbers and so on, changing numbers, and see what's going to happen. And if you make something interesting or not interesting, if you want to share something, please write in the comment down below. Probably you cannot share URLs, but you can share the code, I think. So that will be great. I appreciate it. And also you can share it in the Facebook group, Discord group, Mastodon, or whatever, where live coders are. And I think it's a great way to learn by sharing what you make and also see what others are making. And if you find this video useful, it will be great if you can hit the like button. And if you haven't, please subscribe, and hope to see you in the next video of the Hydra book reading club. Thank you.